An interesting trig question here, and I've got to be honest, I went down the wrong path a couple of times before finding the right route. So the first thing I'm going to do, we've got cot, tan, sec going on, and then we've got tan of 78 and sec of 78. Okay, first thing I'm going to do is write cot 2x as cos 2x over sine 2x. It's not like it's cot squared and we can start using identities. So I'm going to try and get it in terms of more simple trig functions. And I'll write tan 78 as sine 78 over cos 78. Well, that still looks quite complicated, but let's get it over a common denominator. So this is going to be identical to cos 2x cos 78 minus sine 2x sine 78. And suddenly this starts looking a lot better because the top line is very much like the cos addition formula. Cos a plus b is cos a cos b minus sine a sine b. So in fact this here is going to become cos of 2x plus 78. It feels like a good idea to go down that route, even though that then, brings in um, not just an x or a 2x, but if you actually try and expand cos 2x into a sort of formula involving cos x and so on, then it doesn't work out. You have to go down this route. So we're left with cos 2x plus 78 equal to sec x sec 78 over 2 multiplied by sine 2x, which I'm actually now going to write as 2 sine x cos x, because it just seems like a good idea to get everything on the right in terms of x. And then, of course, I'm also timesing by cos 78. Sec 78 is actually 1 over cos 78, so these two cancel out. And sec x is 1 over cos x, so these two cancel out, and the 2's cancel out, and suddenly things are looking much better. Cos 2x plus 78 is equal to sine x. This is still a little bit awkward, but what I can do is rewrite sine in terms of cos. If you think about it, cos looks like this. Actually, I want to... No, that's okay. Yeah, this is y equals cos x. And then to get sine x, I actually end up translating by 90 in the x direction. So y equals sine x is equal to cos x minus 90. Is that right? Let me just check. Yeah, that is okay. And therefore, this is equal to cos x minus 90. So let's focus on solving this equation. It's actually quite tricky. It's not really one that you cover in A-level maths. It's only through doing the advanced extension award or similar problems that you're going to find this sort of thing. There are other questions like this I have seen, but if you're seeing this for the first time, you have to really think carefully about it. Okay, I'm gonna draw a little sketch of cos x. Now, one solution I could immediately get is if 2x plus 78 is exactly the same as x minus 90. They're in the same position. This gives minus the x minus the 78 gives x equals minus 168. So it's a solution, but it's not in our range, so I'm going to reject it. But what if one of the solutions was, say, here, and then one of them was here? I'd get exactly the same value at the end of it, um, because I'm just 360 onwards. So that will give us another possible solution. 2x plus 78 could equal x minus 90, but then I'm going to add 360 on to this one here. That gives x plus 270. So then x minus x on both sides minus 78 is going to equal 192. And that one checks out. That's our first solution. If I add 360 onto the left-hand side, it's actually going to end up being more negative. So I don't need to do that. What I will do is just take a look if I add another 360 on. So 720. But I've got a feeling that this one's going to be too big. So x is going to equal 630 minus 78, and that's going to be greater than 360, so reject.